Okay, welcome back. We're going to factor, and I'm going to probably go through this quicker. So, in class, we will, sorry, this is x, not theta. Doesn't actually matter, but if they were different, it would matter. Okay, now first step is notice that these two are different. So we're actually going to use the Pythagorean identity to get 1 plus cotangent squared x for here, for this, minus cotangent x minus 3. So you get cotangent squared x minus cotangent x minus 2. Now this one should be pretty clear. So you do cotangent x minus 2, cotangent x plus 1. Okay, that's how you do that. So you use trig Pythagorean identities for that. Moving on, simplifying. So you have sine of t plus cotangent t cosine t. Sorry. So notice we can write this as a quotient. So we're going to get sine of t. That didn't change. And we're going to get cosine t over sine t times cosine t, right? Multiply, you get sine t plus cosine squared t over sine t. Now, this is a different function than these two, so let's make this the same. So we get sine t plus, in this case it's going to be 1 minus sine squared of t over sine t. Oh, never mind. My apologies. That's not going to work out well. I mean, eventually you can solve it. This just, okay. Let's correct this point. So cosine squared t over sine t. Now, what we can do is get the same denominator. To get the same denominator, you can multiply both top and bottom by sine t. So the top becomes sine squared of t over sine of t. And since they're the same denominator, we just can add the tops. So sine squared plus cosine squared is going to equal 1. 1 over sine of t. If we simplify this further, 1 over sine of t is going to equal cosecant t. Okay? So that's how you would do that simplified. Okay. Perform addition and simplify. So we get sine theta over 1 plus cosine theta plus cosine theta over sine theta. Now the first step is to get the same denominator. So we're just going to multiply both by what the other has. So this one is going to multiply by this. This is going to multiply by 1 plus cosine theta, right? There are possibly other options to do in solving this, but let's try this one. So sine squared theta plus, okay, this would be cosine theta plus cosine squared theta. And this is all over sine theta times 1 plus cosine theta. Okay, so then we can combine these. So if we combine them, we get sine squared plus cosine squared. So sine squared theta plus cosine squared theta plus cosine theta. Okay, so I just moved this away. Okay, sorry. There's additional stuff. And that's all over this denominator, okay? plus cosine. Okay, so sine squared plus cosine squared is just 1, so 1 plus cosine of theta is on the top. Bottom sine theta, 1 plus cosine theta. Cancel them out. Get 1 over sine cosecant theta. Okay, that's our answer. Okay. Write 1 plus 1 over sine of x, so it's not a function, fraction. Okay. So we're going to do this real quick. So 1 over 1 plus sine of x. So you can multiply both by 1 minus sine of x. Okay. And if you multiply the bottom by that, the top, you end up getting 1 minus sine of x on top over 1 minus sine squared x. Okay, that's just multiplication. This is conjugate. So then this bottom thing will become cosine of x. So 1 minus sine of x. Now you can split the top, so you can get cosine squared of x. So you get 1 over cosine squared of x minus sine of x over cosine squared x. Okay. Now what's 1 over cosine squared x? Well, that's just secant squared x. And then this would become sine of x over cosine x times 1 over cosine x, right? So sine over cosine is tangent times secant of x. So our answer is secant squared x minus tan x times secant x. Okay, we're going to work through many problems, so don't worry if this is difficult. Okay? Okay, let's do a few more. So 8 and 9. So 8, we're substituting in. So they give us x equals 2 tangent of theta, and we have to turn this into a trig function. So again, we're going to just substitute 2 tan of theta squared. And if you square 2 tan of theta, you get 4 minus 4 tangent squared theta. Okay, we can factor off of 4. So we get 4, 1 minus tan squared theta. Is there any function that works with 1 minus tangent squared theta? Sorry, this should be 1 plus. That makes sense. Sorry, this should be plus. I changed it to minus. I was like, this isn't going to work. Okay, plus. So this is all plus. 1 plus tangent squared of theta is something we know. So we get 4 secant squared of theta. Okay, secant squared of theta and 4 is going to cancel, so we're going to get, it's going to be square rooted. So we get 2 secant of theta. Okay? So that would be our answer right there. Okay? Now we're going to rewrite natural logs to be 1 natural log and without fractions. So natural log, absolute value of cosecant theta, plus natural log of tangent theta. Now if you put them together, you get natural log of cosecant theta times tangent theta. Now the first thing we do is we turn these into sine and cosine, so it's easier to deal with. So we have 1 over sine theta times sine theta over cosine theta. 1 over sine theta, cosine theta, the sines are going to cancel. So you get 1 over cosine theta, and natural log of 1 over cosine theta is natural log of secant theta. And that would be our answer right there. Okay? Simply canceling out the things we need to. Okay? And that's going to be it for today. We're going to meet in class and work through some problems from the book. Okay? I'll see you shortly. Okay. Bye.